Hello everyone. Today starts the factoring part of this unit. So this is a factoring flowchart and you have two options. You can either copy it all down onto a piece of paper or print it. I have attached the PDF in this class assignment. I'm going to be referring to this factoring flowchart the entire time. And if you go through this flowchart, it'll help you decide how to factor everything. So for today, we're going to be focusing on the very top of our factoring flowchart, the GCF. We're going to work our way down from there to decide how many terms something is. So if it's a two-term polynomial, three terms, or four terms, and be talking about the different ways to factor. But today is just that main basic step of factoring out a GCF. Now, a GCF is the greatest common factor. You guys probably have heard that before, probably in like 5th, 6th grade when it was just numbers, and now we're going to be dealing with the GCF with numbers and variables in a polynomial. So the way this works is the first thing you do is you look at the coefficients. So those are just the numbers themselves, the coefficients. And you're going to find the largest number that both of them can be divided by. That's the first part of the GCF. The second thing you're going to do is look at the variables. Now, if they share a common variable, like they both have x's or they both have y's, you're going to find the smallest exponent in the variables. So like maybe the smallest exponent is a 2 or a 3. A lot of times it's just going to be a 1. And I'll show you what I mean by that in just a little bit. So let's start with one of the problems. Number 1, 3x plus 12. So the coefficients are 3 and 12. And the largest number you can divide both 3 and 12 by is a 3. They do not have a variable in common. One of them is just a constant and doesn't have a variable, so I can't take out a variable. Now this is why we did distributing before, because factoring out a GCF is like undistributing. So it's kind of like saying, okay, 3 times what gave us 3x? That was 3x. 3 times what gave us a positive 12? That was a positive 4. So it's like you're going backwards. I gave you the answer. What was the problem that you distributed to get that answer? And that would be 3 times x plus 4. So let's try another one. 6y to the fourth plus 14y to the third minus 10y to the second. So first, if we just look at the coefficients of 6, 14, and 10, we have to find the largest number we can divide all three of them by, and that's just a 2. Then we say, do they all have a variable in common? Yes, they all have a y. So it's going to be a y, and if you look at the exponents, the smallest exponent is a 2. And when we start doing our distributing, I'll explain again why it has to be the smallest. So we're looking for the smallest exponent on that common variable. So now let's do our undistributing, because that's what factoring really is undistributing. It's going backwards. So 2y squared was multiplied by what to get 6y to the fourth? That would be a 3, because 2 times 3 is 6, and a y squared, because y squared times y squared is y to the fourth. Now for our next term, what was it multiplied by to get a 14y cubed? That would be a positive 7, because 2 times 7 is 14, and a y to the first, because y squared times y is y cubed. Then last, 2y squared was multiplied by what to get a negative 10y squared? That is a negative 5. But notice that we already have enough y's. Therefore, that term doesn't have to have any more y's. Now, that's why we have to look for the smallest exponent, because in this last term, the most amount of y's you can take out is 2. So if I had tried to factor out 3, I didn't have enough to actually take out 3 y's. So you have to find your smallest exponent. Okay, so that is the GCF factored out. If I just double check to make sure that I did this correctly, 3, 7, and 5 only have a 1 in common, so I factored out the largest number possible, and they don't all have a variable, so I took out enough y's. Okay, let's try another one. 15a squared b minus 30ab. So sometimes you'll have more than one variable. That's okay. So our coefficients, 15 and 30, The largest number we can divide them both by is 15. So sometimes it is one of the numbers. They both have an a, and the smallest exponent is my a to the first, so I'm just going to take out an a. They both also have a b, so I'm going to take out a b, and again, my smallest exponent is that 1. So let's figure out what we multiplied by. 15ab was multiplied by what to get a 15a squared? Well, my 15's already there. A squared came from a times a, and my b's already there. So all I was missing was an a. Then 15ab was multiplied by what to get negative 30? So 15 times negative 2 gets us the negative 30, but there's already an a and a b, so I don't need any other variables. So 15ab was multiplied by a minus 2. Okay, number 4 of 5. Number 4, if we look first at the coefficients, so go pieces. Yes, it looks like there's a lot of pieces to this, but look at small sections first. So if I just concentrate on the 12, the 36, and the 6, the first number, the largest number, you can divide them all by is a 6. Okay, so that's just the coefficients. Now let's look at variables. They all have an m. The smallest exponent of the m is a 3, so I'm going to take out an m cubed. They all have an n, so I'm going to take out an n, and the smallest exponent of the n is a 2. It's actually in 2 places. That's fine. So I'm going to take out a 6m cubed n squared. Now let's do our figuring out what we multiplied by to get what is now our problem. So 6m cubed n squared was multiplied by what to get 12m to the 5th n squared? So pieces. 6 times 2 is 12. M to the 3rd times m squared would get you m to the 5th, because remember, that's adding exponent rules. And n squared, we already have an n squared, so we don't need to have any other n's. Then if we say what was multiplied to get the middle term, 6 times negative 6 is negative 36. M to the 3rd times m to the 1st gets us m to the 4th. And n to the 1st times n squared gets us n to the 3rd. So I have to make sure all of my exponents add to the originals. And then for the last one, 6 times negative 1 is negative 6. And my exponents are already fine. I already have an m to the 3rd and an n squared, so that's all I need for the last term is a negative 1. If I just double check my work, 2, 6, and 1, the highest number I can divide them all by is a 1, so that really doesn't do anything. They don't all have an m inside of parentheses, and they don't all have an n inside of parentheses, so that is fully factored with the GCF. Now the last one, the reason I'm showing you this one is if the first term is negative, factor it out. Factor out that negative sign. So we might have a negative 1 or an actual negative non-1 number that we're going to factor out. So if you look at this trinomial, that has a negative in our first term, our leading term, our highest exponential term. So when I factor, I'm going to factor out a negative something. If I look at the rest of the numbers, 2, 6, and 8, the highest I can factor out of that is a 2. So I'm going to factor out a negative 2. I can't factor out an x because the last term is a constant. So negative 2 was multiplied by what to get negative 10x squared? That's 5x squared. Negative 2 is multiplied by what to get a positive 6x? Be careful with your negatives. That's a negative 3x. And negative 2 is multiplied by what to get a negative 8? That's a positive 4. But what that gives us is a polynomial inside parentheses where that first term is positive, and that will help us in our next set of factoring. So today's word of the day is GCF. It's a little bit more of a phrase, a 3-letter word, 3 letters, GCF. Your assignment is the greatest common factor. You're going to have a couple problems that look just like the assignment, and it is going to be due on Tuesday, April 7th. Okay, so if you have any questions, email me, come to office hours on Wednesday, write to me on Google Classroom. Let me know. Do not just sit there confused, not doing anything. It's not helping you. I am here to help you. So ask. Okay? Hope you are staying safe and not getting too bored. Have a good day.